Okay, seventh grade. Now we're going to be reviewing for the grade 7 topic test review for topics 3 and 4. Okay, so please have out your study guide that I gave you. And if you don't have it, please copy down these questions. And so in between those questions, please leave space so that way you can fill it in as we go. Okay? And remember, if you have any questions or comments, please leave them in the comments area. All right, I'm going to scroll down so you can see the complete question for question 1. It says 1 dozen of cupcakes requires the following ingredients. All right, so I'm going to scroll down so you can see all of the ingredients along with the question that they want you to answer. So we have 1½ cups of flour, 1/2 cup of blueberries, 3/4 cup of chopped pecans, 2½ cups of brown sugar, 5/8 cups of white sugar, 1/4 teaspoon of salt. So Miss Mitchell wants to double the recipe. How much of each ingredient should be used? So when they say they want to double the recipe, double means 2. So therefore, if we want to double the recipe, we'll have to use multiplication. Okay? So we want to multiply every ingredient times 2. Because if they said, if I wanted to triple the recipe, then you would multiply times 3. Okay? So we are going to multiply every ingredient times 2 because we want to double the recipe. So how much of each ingredient should be used? So the first thing we're going to do is the 1 1/2 cups of flour. So the first thing you'll see, it is now a mixed number. So we'll have to change that mixed number into a improper fraction. So 1 1/2. 1 1/2. To change a mixed number into an improper fraction, remember you're going to take this whole number, multiply it by the denominator, and add the numerator. 1 times 2 is 2. 2 plus 1 is 3. So now our numerator is 3. And we're going to keep this denominator as 2. And remember, now we want to double the recipe, so therefore we'll multiply times 2. 2 is a whole number, and we want to make it a fraction. And remember, when we want to make a whole number a fraction, we're just going to add 1 in the denominator. And now we're ready to go. Remember, with multiplying fractions, you just multiply straight across. Okay? Not crisscross. You multiply straight across. 3 times 2 is 6. 2 times 1 is 2. Okay? From here, this is an improper fraction. 6 is bigger than 2. Okay? We cannot leave that like that. Okay? As if they have it in the options for the answer, fine. But ordinarily, you do not leave it like this. We have to divide. When we divide, remember this numerator goes into the house. The denominator is outside. 2 goes into 6 3 times. 2 times 3 is 6. So therefore, we're now going to use 3 cups of flour. Now we can move on to the blueberries. 1/2 cup of blueberries is already a proper fraction, so we don't have to do anything to it except multiply. 1/2 times 2/1, because remember, we're doubling the recipe, we're multiplying by 2, and 2 is a whole number, and we want to make it a fraction, so therefore we have to add 1 to the denominator. 1 times 2 is 2, 2 times 1 is 2. Whenever we get 2/2, 1/1, 3/3, the same numerator for the same denominator, therefore it will equal 1 whole. So therefore we're using 1 cup of blueberries. All right, so now we're moving on to 3/4 cup of chopped pecans. 3/4 is a proper fraction, so therefore we do nothing to it. 3/4 times 2 over 1, because remember we're doubling the recipe. 3 times 2 is 6, 4 times 1 is 4. We have an improper fraction. Remember, in your options, if it is listed as an improper fraction, fine. But if it is not, normally you will not ever leave it like this. You will have to change it into a mixed number. So when we divide 6 divided by 4, 4 goes into 6 one time. 4 times 1 is 4. 6 from 4 is 2. We have to make a decimal, or we can make it a fraction. How? If we were to, I'll show you both ways, okay? If we were to make it a decimal, remember we'll just put our decimal and then 2 zeros. We'll send this 0 down. 4 goes into 20 5 times. When you put the decimal here, please do not forget to put it up top, okay? So therefore it will be 1.5. If we were going to just make it a fraction, we will still divide. 4 goes into 6 once. 4 times 1 is 4. Our remainder, 6 minus 4 is 2. Here we have a remainder. We're going to take this remainder and put it as the numerator. And we're going to take this number and then put it as our denominator. But we're not done. Why? Because we can reduce. And I don't know if you can see this over here, so I'm going to bring it over. All right. Here we can reduce 2 over 4. We find a number that can go evenly into the numerator and evenly into the denominator. In this case, it is 2. 2 goes into 2 one time. 2 goes into 4 2 times. So now we have our answer, 1 1/2. Okay? If you need to pause the video to take down these notes on how to turn a fraction into a decimal or a fraction into a mixed number fraction, then please do so. I'm going to erase. So now we have 1 1/2 chopped pecans. All right, now we're moving on to 2 1/2 cups of brown sugar. Here we have an improper fraction. Excuse me, we have a mixed number, I'm sorry. All right, and first we have to change this mixed number into an improper fraction. Remember, we multiply the whole number times the denominator, add the numerator. So 2 times 2 is 4, 4 plus 1 is 5. So now we have 5 over 2, because remember we're going to keep that denominator. Now we're ready to go. So we're going to double the recipe, 2 over 1. 5 times 2 is 10, 2 times 1 is 2. When we divide 10 divided by 2, we get 5. So now we have 5 cups of brown sugar. Okay? Now we're going to move on to 5/8 cup of white sugar. And we're going to double it. 5 times 2 is 10. 8 times 1 is 8. Here we'll have to divide. 10 divided by 8. 8 goes into 10 one time. 8 times 1 is 8. 10 minus 8 is 2. 2 is our numerator, 8 is our denominator, but we're not done. We have to reduce 2 over 8. We find a number that can go evenly into the numerator 2 and evenly into the denominator 8. In this case, it is 2. 2 goes into 2 one time. 2 goes into 8 4 times. So therefore, we will get 1 1/4. So we have 1 1/4 cups of white sugar. Now we'll go on to 1/4 teaspoon of salt. 1/4 times 2 over 1. 1 times 2 is 2. 4 times 1 is 4. From here, we just need to simplify. 2 goes into 2 one time. 2 goes into 4 2 times. So we're using a 1/2 teaspoon of salt. All right, so there. How much of each ingredient will I be using? So I'll now be using 3 cups of flour, 1 cup of blueberries, 1 1/2 cup of pecans, 5 cups of brown sugar, 1 1/4 cups of white sugar, and 1/2 teaspoon of salt. All right, so please, I understand that this is a lengthy process. It's long, yes, I understand that, but please do not be lazy and just go ahead and do this, okay? Now we'll move on to number 2. All right, number 2. And number 2 is right here, okay? What is the value of the expression below? We have -1/3 times, in parentheses, 5 minus 1/2, okay? So -1/3, and then in parentheses, we have 5 minus 1/2. All right, so here, you are combining multiplication and subtraction, okay, of fractions. So by now you should know how to multiply, add, subtract, divide fractions. So the first thing that we need to do, we have parentheses. And remember, please excuse my dear Aunt Sally, parentheses, expressions, multiplication, division, addition, subtraction, okay? So the first thing that we need to do is do what's in parentheses, but we have this out here. We need to distribute, okay? So we have to distribute this -1/3, all right? When we do that, we have to multiply. When we multiply, we are multiplying -1/3 times 5. And remember now, this is a whole number. We make a whole number fraction by adding 1 underneath. And remember, we multiply straight across. -1 times 5 will give us -5. 3 times 1 will give us 3. Being that we're not done, because remember, we still have to plug this back into here, leave it as an improper fraction, okay? Do not turn this into a mixed number because of the fact that we have to turn it right back into an improper fraction to complete the problem, okay? Now, I boxed this so that way we won't forget. We are now replacing this number with this, okay? So that way we do not get lost in our work. Now, we are going to multiply -1/3 times -1/2. And the reason why this is -1/2 because of this sign, okay? So, -1 times -1 will give us a positive. Why? Because a negative and a negative will equal a positive. So -1 times -1 will give us 1. 3 times 2 will give us 6. So now we can go ahead and plug everything back in. So now we'll have negative 5 over 3 times 1 over 6. Excuse me, minus. All right? So now we are subtracting negative 5/3 minus 1 over 6. We can't just simply subtract it. Why? Because we need a common denominator. The LCD, least common denominator, okay? I like to put it vertical. If you like working horizontal, straight across, that is fine, okay? So here, we're just gonna take this negative 6 and put it, negative 1 over 6 and put it down. All right, so now we need a least common denominator. So when we find our least common denominator, what I like to do, I just like to do multiples. So the multiples of 3, 6. Oh, multiples of 6, 6. And we can stop there. Why? Because that's the least common denominator. There's no need to go further, because if we do, we'll have to reduce later, okay? So our least common denominator is 6. From here, 6 times what gave us 6? 1. So if 6 times 1 gives us 6 here, we'll use that 1 on top. 1 times 1 will give us 1. 3 times what gave us 6? 2. And what we use here, we can use right here. Negative 5 times negative 2 will give us negative 10. So from here, negative 10 minus 1 will give us negative 11. Okay? Remember, don't forget this operation, okay? So remember, negative 10 minus 1, remember, when it says minus, we're moving to the left of the number line. Negative 10 minus 1 gave us 11, and we're going to keep this denominator of 6. So remember, if in the option they have it as an improper fraction, fine. But if not, you'll have to change it into a mixed number. And how do we do that? We just divide. 11 divided by 6. 6 goes into 11 one time. 6 times 1 is 6. 11 minus 6 is 5. So 5 is our numerator, and then we keep this 6 as our denominator. And remember, don't forget that negative sign. So now our answer will be negative 1 and 5 over 6. So what is the value of our expression below? It is negative 1, 5 over 6. But remember, like I said, if in the option they have it as an improper fraction of negative 11 over 6 or something like that, then that is fine. Choose that answer, okay? Now let's go ahead and move on to number 3. All right, number 3, which is right here. Write all the possible ways that would be equivalent to negative 4 over 3. All right, so we have negative 4 over 3. Now, they want us to write all the possible ways that will be equivalent to. That means that it'll be equal to it. That means we're not changing the value of this number, okay? We're not changing the value of the fraction. We're just making it so that it still be equivalent, okay? Notice where they have the negative, okay? They have the negative connected to the numerator, all right? So another way that we can write it, and we won't change this value, is that we can write it with the negative here. So it'll be just be negative 4 thirds. So as you can see in here, this negative was connected to the numerator. Now it is connected to the entire fraction. It didn't change its value. We just changed where the negative sign was. Another way that we can write it, if it was connected to the numerator here, guess where we can also connect it? to the denominator. So now, instead of negative 4 over 3 or negative 4/3, we can write it as 4 over negative 3. As you can see, all of these did not change the value of this fraction. Okay, all we did was write the negative in different locations. Here is connected to the numerator. Here is connected to the entire fraction. Here it is connected to the denominator. It did not change the value. It is still equivalent to this. This is equivalent to this. This is equivalent to this. This is equivalent to all of these, and this is equivalent to both of these. Okay? So remember, in the question, when they ask you, write all the possible ways that negative 4 over 3 is equivalent, all of these ways are equivalent. Okay? Let's move on to number 4. All right. Now we're moving on to number 4, which is this word problem right here. And it says, Kayla was using a recipe for a big order of pancakes for the class that required 1/2 tablespoon of nutmeg. Instead of making one big order, Kayla decided to use the recipe to make 2 small orders. How much nutmeg should she use for each of the 2 small orders? So she is making pancakes that requires 1/2 tablespoon of nutmeg. So 1/2 tablespoon of nutmeg. And that was for a big order. But she doesn't want to make a big order. She wants to make 2 smaller orders. Okay? So how much nutmeg should she use for each of the 2 small orders? We're going to have to divide. Why? Because we're going from a big order to 2 small ones. Okay? So we're going to have to divide by 2. And remember that when we divide by 2, 2 is a whole number. We have to make this whole number a fraction. And we do that by adding a 1 in the denominator. So now we have 1/2 divided by 2 over 1. Remember, when we are dividing fractions, now we have to take the reciprocal, okay? We keep this first fraction the same. I repeat, keep this first fraction the same, okay? 1 over 2. Now, since we are dividing fractions and we have to take the reciprocal, now we have to change this operation to multiplication. After we change the operation to multiplication, we now have to take the reciprocal of 2 over 1, and now we have 1 over 2. Remember, we only take the reciprocal of the second fraction. When you set up the problem, you will take the reciprocal of the second fraction, not the first. Please don't do that. So now we have 1 over 2 times 1 over 2. And remember, we multiply fractions straight across. 1 times 1 is 1, 2 times 2 is 4. And so now we know that in order for Kayla to make 2 small orders of pancakes for the class, she'll have to have 1/4 tablespoon of nutmeg for each of the orders, okay? So remember, if you need to pause the video, please pause the video so that way you can take these notes and understand them, all right? And let's move to number 5. We can clearly see number 5 at the bottom, and that is right here. Number 5 says, what is the decimal form of 5/12? All right. You will be working with a calculator, okay? So when we input 5/12 into the calculator, okay, we're taking the decimal form. That means that we have to divide, okay? We're going to put 5 into the calculator, hit divide, because that's what this line means. It means divide, and then 12. So when we divide 5 divided by 12, we should get 0.41666666. Notice that these sixes are repeating, okay? But we are not going to write this. Why? Because we can use another method to do that. And that method is using the repeating bar across those sixes. So we'll write 0.4166 and put a bar over those sixes to show that they repeat infinitely many times. Okay? So what is the decimal form of 5/12? It is 0.466, and that 66 is repeating. Okay? So remember, when you are turning a fraction into a decimal, in your calculator, you're going to put 5 and hit divide, and then the denominator, which is 12. Okay? Or if you're doing it by hand, 5 will go into the house, 12 will go outside. 12 cannot go into 5. So therefore, you have to put a decimal with 2 zeros. Okay? Remember, when you put that decimal here, you're going to put it up top. And then you will then go ahead and divide. 12 can now go into 50 4 times. 12 times 4, 4 times 2 is 8. And then that 4. 50 minus 48 is 2. We're going to bring this down. And so here we have 20. 12 goes into 20 one time. 12 times 1 is 12. 20 from 12 is 8. We have to have another 0. And this is where our 6 repeats. Okay, so 12 goes into 80. 12 goes into 86 times. And then you will get a repeating 6. All right? So now go ahead and take your notes, pause the video if you need to, and then press play when you are ready to move on. We are going to be moving on to number 6. All right, number 6. And we are right here. The temperature rises 10 degrees Celsius and then drops by 4 degrees. If the temperature started at -15, what temperature change would be required to bring the temperature to 0 degrees Celsius? All right. The temperature rises 10 degrees Celsius and then drops by 4 degrees. If the temperature started at -15, what temperature change would be required to bring the temperature to 0 degrees Celsius? Listen, always read word problems over and over again until you understand what they want you to do. Okay? So, if I were you, I would set it up into an equation. All right? So, it says that the temperature started at -15. You see? It started at -15. So, that is our starting point. So, therefore, if it started at -15, that is where we will start. It started at -15. Then we go back into the problem. It says the temperature rises 10 degrees Celsius. So it rose. Therefore, we'll represent this as a positive 10. Then it says it dropped by 4 degrees. So therefore, if it dropped, it went down. So now we'll represent that dropping 4 degrees as -4. So then it said that what temperature change would be required to bring the temperature to 0 degrees Celsius. We have to solve this, and whatever our answer is, we have to see what will need to happen to bring it down to up or down to 0. Okay? So -15 plus 10. Remember, it's -15 and it's plus, so on the number line we have to move to the right 10 units. Okay? So when we do that, we're at -5. Okay? Then we minus 4. So -5, we're already at the negative, and we minus, that means that we have to move to the left of the number line, how many spaces? 4 spaces. So remember, when we're moving to the left of the number line 4 spaces from -5, we will then be at -9. So we have our answer -9, but we're not done, because they asked what would be required to bring the temperature to 0 degrees Celsius. All right, so on the number line, here is 0, here is -9. So how many spaces do we have to move to bring this to 0? We have to move 9 spaces, okay? So therefore, we just have to move 9 spaces. So we move 9 spaces to 0. So when we're talking about degrees, so if we're at -9, we'll have to increase by 9 degrees Celsius, and that is it. So please pause the video. Please take notes. If you need to rewind to get more understanding, please do so. If you still don't understand, please comment in the comment area so that way I can help you. And we'll be moving on to number 7. All right, number 7. DeAndre wants to save at least $550 to buy some rims for his new car. He has $154 saved already. How much does he need to continue saving to buy the rims? So remember what I said about word problems. Read them over and over again until you understand what they want you to do. Then look at your options. Look at your options because you need to know how to answer the question. Number 7 says DeAndre wants to save at least $550 to buy some rims for his car. He has $154 saved already. How much does he need to continue saving to buy the rims? So he already has $154. But they said how much does he need to continue saving to buy the rims? So he already has $154. He already has it. But the rims are $550. So therefore we need to find the difference between $550 and $154. So therefore we are going to subtract. And when we do, we'll have $396. So therefore, he needs to save at least $396, okay? So when they say at least, that means that he can save $396 or he can save more. So please look at the options. Go through the options to find at the least the amount of money that he can save. So in this case, he just needs to save at least $396. So could he save more than $396? Yes, he could. Okay? So, but please go through the options so that way you know that it'll either need to be that amount or more. Okay? It can't be less than this amount. It has to be this amount or more. Okay? So, since number 8 is already showing, we'll move on to number 8. Number 8 says, last school year, Malik sold hot chips and soda at the dance. He sold 20 hot chips and 22 sodas at the Christmas dance, and 18 hot chips and 42 sodas at the Valentine's Day dance. If hot chips and sodas cost 50 cents and 75 cents, how much money did Malik make last school year? So here, we have multiple things going on in this problem. And it's going to be multiple things that you are going to have to do. So he sold 20 hot chips and 22 sodas at the Christmas dance, and then 18 hot chips and 42 sodas at the Valentine's Day dance. So, but they're saying that hot chips and sodas cost 50 cents and 75 cents. How much money did Malik make last school year? So we are combining all of these amounts. So the first thing that we need to do is set up this problem. So here, now, let's see, he sold 20 hot chips and 22 sodas, and then 18 hot chips, 42 sodas. So hot chips, let's deal with hot chips first. So he sold 20 hot chips and then 18 hot chips at these dances. So first thing we need to do is add 20 plus 18. 20 plus 18 will give us 38. Okay? So that's hot chips. Now sodas. He sold 22 sodas and 42 sodas at the dances. 22 plus 42. Okay, these are sodas. So now we have our combined amount of hot chips right here and sodas right here that he sold at the dance. Now, it says that hot chips and sodas cost 50 cents and 75 cents. So when they have it like this, you follow it in order. Hot chips was first, so therefore this amount was first. Therefore, the hot chips were 50 cents. I'll go through that again. They said here, if hot chips and sodas cost 50 cents and 75 cents. You see this? They have it in order. Hot chips and sodas. Hot chips and sodas. Okay? So leave it in that amount. Do not switch those around. All right? So hot chips were 50 cents. And then they said that sodas were 75 cents. All right, so that's the amount that it was. Now, we know that the total number of hot chips were 38. And we know that the sodas, the total amount of sodas that was sold was 64. So now we're ready to go. 38 hot chips times 0.50, so 50 cents, plus 64 sodas times 0.75 or 75 cents. So the first thing that we need to do now is multiply. 38 times 50 cents will then give us $19. 64 times 75 cents will then give us $48. And all we now have to do is add $19 plus $48, and that will give us $67. So, how much money did Malik make last school year? He made $67. Okay? So, did you see how we had to do multiple things in this problem? Don't be lazy. Do it. Okay? The first thing we needed to do was find out how many hot chips in total did he sell, which was 38. Then we had to find out how many sodas did he sell, which was 64. Then we had to create an equation. We knew that hot chips sold for 50 cents. So we had to multiply 38 times 50 cents would give us $19. We knew that soda sold for 75 cents. So therefore we had to multiply 64 times 75 cents would then